equation of tension and the equation of normal to a circle. The equation of tension to the curves at the P given by y minus yt equals to the mt times x minus xt. Okay, question 1. Find the equation of tension of the following curves at the given point. Y equals to the 2x squared minus 4x minus 3 and x here equals to. Okay, given the quadratic function y equals to the 2x squared minus 4x minus 3, and you find the first derivative dy over dx. Okay, differentiate y with respect to x. First derivative equals to the 4x minus 4, and then when x here equals 2, you find the gradient of tension. So you substitute 2 here into the first derivative, and dy over dx here equals to the 4. Yeah. So the gradient of tension mt here equals to the 4. And then you find the point x and y, and x here equals 2, and you substitute into the function, and the y here equals to the negative 3, and this one 2 negative 3. Okay, and you find the equation of tension using this formula y minus yt equals to the mt, or the gradient of tension, times x minus xt, and given the gradient of tension mt here equals to the 4. Okay, the gradient of tension mt equals to 4, and the point xt yt equals to the 2 negative 3. Yeah, and you substitute the value y minus 3 equals to the gradient of tension 4 times x minus 2. Here equals to the y plus 3 equals to the 4x minus x. Yeah, and you write down the equation here in a general form. Y minus 4x plus 11 and equal to the 0. Okay. Or you can write down the final answer here in terms of ax plus b. So y here equals to the ax plus b, and the final answer here equals to the y equals to the 4x minus 11. Okay, so you can choose first option. You write down the answer here in a general form. Okay. And second, you can write down the answer here in terms of x plus b, y here equals to the 4x minus 11. Okay, equation of normals, the gradients of normals here equals to the mn equals to the negative 1 over mt. So the mt times mn here equals to the negative 1. Okay, and the equation of tangent y minus yn equals to the mn, the gradient of normals, times x minus xn. Okay, question 2, find the equation of normals at the given point xy plus 2x squared equals to the 3y squared plus 12, and the point here at the 3, 2. Okay, first step, you find the first derivative of the function, and the method here using the implicit differentiation. Okay, using the implicit differentiation, x dy over dx, here plus y plus 4x, and then the right hand side here equals to the 6y dy over dx. Yeah, you combine the dy over dx, 6y minus x, and the right hand side here equals to the 4x plus y, and the first derivative dy over dx here equals to the 4x plus y over 6y minus x. Okay, and then you find the gradient of tangent. Okay, gradient of tangent when x here equals 3 and the y here equals 2, and you substitute into the first derivative, and the dy over dx here equals to the 14 over 9. This one, the gradient of tangent mt equals to the 14 over 9, and then the gradient of tangent mt times gradients of normals equals to the negative 1. 14 over 9 times mn equals to the negative 1. Mn here, or the gradients of normals, equals to the negative 9 over 14. So this one, the Mn. Okay, and the gradient of tangent Mn equals to the negative 9 over 14. Xn, Yn here equals to the 3 and 2. And using the equation of normals, y minus yn equals to the Mn, gradient of tangent, times x minus xn. Y minus 2 equals to the negative 9 over 14 times x minus 3. And answer here equals to the 14y plus 9x minus 55. Yeah. Okay, this one the equation of the normals.